series looks familiar to you. Maybe it does, maybe it doesn't. But you got the nth term right. So the nth term is just x to the n, right? So I want you guys to try to find the interval of convergence complete with endpoint analysis to figure out what the interval of convergence is for this.
Oh, ratio test.
Yep.
Oh, there we go.
Make sure it's less than 1.
Hey, and remember with these, if you tend to write in like 2.5-inch tall letters,
You should have seen my class essay.
shrink it down.
Huge.
I took up 9 pages, 6 letters per page. Yeah, so if you need to keep back what we did last time, this one right here will be just like what we did last time. And we'll do a couple more of these today. We'll see if we can take those old skills from last time and continue to apply them to this new question.
Wait a minute. No.
Let's see. So
it's just like in the class.
set up your ratio, and you set up convergence, and the limit doesn't even really apply to this anymore, so you get this, so you get that, and then you try out the increments.
Oh, those simplify, don't they?
Looks reasonable.
So I, oh, go ahead. I have a question. Right the last one, thinking that we come out this morning.
Yeah.
So
Is it just,
why does this diverge? Well, because I was just thinking, so like you just kind of said it diverges, but I wasn't sure why. Because I got negative 1 and 2n if you combine the exponent.
Okay, sure. And what's negative 1 to the 2, and like, what's another way to write that? You know, I know why this is, because I actually wrote this part, I wrote this on the board, because I was just kind of standing up here, so I just threw it on the board really quick.
that's why.
So if you have this,
Geometric series works if r is less than 1.
would you agree that that's the
works.
same as,
That it converges.
Yeah. Oh, so this should one
Life.
be
I just found out that my birthday is the same day I was born.
Okay.
Life is crazy.
I actually wrote it right there in that exact same spot.
Dude,
Sorry, I didn't put that on.
that's like a 1 in 300 chance.
And a quarter.
Yeah, so then that's just an
And a
nth term
quarter.
test, right? The limit is n goes towards
So if
infinity,
you
it's
turn
not 0,
17,
it's 1.
And what about negative 1? You're 16. Parentheses to the end.
Yeah, so that one also,
Wendy turns
So this
Deciding on
one-
colleges. I'm 16.
if you actually write out the nth term test,
You're really young. How old are you saying?
you have to look at this and say, well, the last term is either negative 1 or positive 1,
So
right?
it's just not 0.
It's just
I
not
barely
0.
even know when that's all.
That's the point.
Because it's the day after mine.
Some people would say
My birthday's on a
diverging by
Monday.
oscillation, because it's just like oscillates, and it never, but just to get the nth term's not 0. Yep.
26 is like so close to perfection.
Pay attention to the video.
25 is so good.
Yeah, I don't remember.
Hey, maybe one of the real big benefits to all this for you this year
Wait, and
is
then you tested it?
gaining confidence that you can like take a video, take some notes, and learn from that. And know what you do know and know what you don't know and address the things you don't know. So that's a good skill for college.
How do we,
Sure.
Mr. Anderson?
Yes, sir.
I know that the sum from n equals 0 to infinity of negative 1 to the n diverges. Is it because the nth term test, like it doesn't?
It doesn't equal 0.
Doesn't equal 0.
Yep. If that nth term isn't 0, if it's anything other than 0, including
No, maybe
it's either 1 or negative 1, depending on where you stop,
And then I'll change it.
then if it's not 0, that limit's not 0, then
The nth term test is the limit is in approaches infinity of.
No, I know.
of the
No, it's just
nth
'cause
term.
like
In this case, it would be x to the n.
That's why. It
So
wasn't
negative
obvious.
1 to the n.
But if you're testing endpoints, it would either be 1 to the n or negative 1 to the n.
So that divergence is negative 1 period, it just doesn't equal 0.
It doesn't equal 0.
So they both diverge?
Correct.
Because both
Quick refresher on the memory because we haven't done this. How would I justify that just 1 to the n diverges?
I would do limit as n goes towards infinity. I would do an nth term test, really.
Okay.
Because remember that, like, I feel like that nth term test, like, is the mean coach. And if you can get
Oh,
past
this
the
just doesn't
mean,
equal zero.
if you can get past the mean coach, then all these other opportunities open up to you, but if you can't get past the mean coach,
Yeah.
you're never gonna
So, no.
convert.
Is that
I would
what
always
you
start
know?
with
That's
that.
more props for Santi.
Cause it's
Let
like,
me have a clap for Santi.
Why?
I got a full ride to Villanova yesterday.
Oh, sweet.
Yeah, clap for Santi.
Hey, after all those years of making fun of me for Philadelphia, you might be going there.
I might be, I know. That's the
How's
issue.
that going?
That's the issue. Like, he's not paying for it. Right.
Okay. Still Philadelphia.
He still has to live in Philadelphia for a while.
Philly for Philly.
Watch Santi come back with some Philadelphia accent, acting all tough and everything.
Okay, you're saying on. Instead of on.
Is that a thing?
Oh, totally.
Oh, okay.
Oh, totally.
Like I have it tattooed on me, bro.
And then when you ask questions, you're gonna do it in like a rising tone.
Try it.
Wait, hold on. And see if I can.
Yeah, so we can get an example of that.
So does it converge? so it does converge?
But it's almost like it's sort of like a challenging, tough guy way, right?
Oh, yeah. If
Yeah,
it's in
it's like
Philly,
this.
It's gonna be a bit more. of a- That's
There you
that's
go.
New York.
Yeah, that is sort of, that's a New York phrase.
East Coast.
He's in the Pacific Northeast or Atlantic Northeast. It's fine.
The Pacific
It's like a 45-minute drive.
That's Siberia, if I remember correctly.
Oh, yeah. Wait, Siberia's not.
Pacific Northeast would be like
Oh.
Siberia-ish, right?
No, that'd
Actually,
be.
not anymore. There was a while where Penn State was
It's
the
like
highest rated
it's like
basketball
Camp
team in
Catchment
Pennsylvania.
or
So.
something.
Yeah, that
Siberia's in.
Right near the Bering Strait, right?
It's like he was excited to
I
get
don't know.
Out there
I just
on the
noticed
edge
him
of
playing
Russia.
Risk. It's the territory is called
Yeah, we
Camp
all know.
Catchment.
Oh, okay.
I feel like
I'm just
to
excited.
get all the seniors to go, they should make us check in at the basketball game, and that's how they load
Well,
up
I
their
have
bags
to
and
dance
stuff.
at it if we're going.
What time do we go?
Okay, hey, let's just see how this went for y'all. Did you guys get your ratio test set up? Okay, so you get your ratio test set up, please listen up. And you get it set up for convergence, and you get here. And I don't know, like, if you want to see or need to see or how important the mechanics are, but wouldn't this lead you to a kind of a provisional interval of convergence of that? Isn't it either -1 or 1 for the endpoints? Because you're basically saying what numbers are less than 1 away from 0. Well, they'd be all the numbers between -1 and 1, right? Anyway, we got to test some endpoints, and this is where most of your questions came from. So if I check out the left endpoint, don't I get sigma of -1 to the n? And this diverges, and the reasoning there would be from that nth term test. The nth term does not go to 0. And so since we get diverging on the left endpoint, we just leave it open. So this would be -1 is less than x. And then the other endpoint, we test out x equals +1. So this would be sigma of 1 to the n. And this would just be, this series would just be 1 plus 1 plus 1 plus 1. So once again, the nth term test would tell us that it diverges because that nth term does not go to 0 or doesn't head towards 0. And so I could complete my interval of convergence by clearly saying that it's open on both endpoints, doesn't converge on either. Oh, go ahead.
So, I can't remember the exact convention of it, but it's like, one of the things, like, we can't say 1 to the infinity equals infinity, we can't say that. But we can say the limit as n approaches infinity of 1 to the n equals infinity.
You mean equals 1? Like that limit equals 1?
Right, yeah. We
Well,
can't
in
s-
this form,
the
yes,
limit
but if
equals
you,
1.
well, so it depends, right? So it depends on what the original expression was. So this is going to be a somewhat unrelated thing, but worthwhile. If I say limit as n goes towards infinity of 1 to the n, I think that eventually I could prove that this is 1. If I say this, I'm going to eventually prove that that's e, even though that indeterminate point in between look the same for both of those. You both get this 1 to the infinity look, kind of on your initial thought. But the one on the bottom gets you e to the first, the one on top gets you 1. So it really kind of depends on what it is you're actually doing the limit of, if that makes sense. So I don't think we can make a blanket statement of like, you can never do this and you can always do that. You just have to investigate each one for what it is. It's a good connection, though. Okay, and I will say this. I'm hoping you know, but maybe you don't. Did anybody recognize what this series is? Ladies, listen. It's geometric, right? Isn't this, remember when we talked about this several days ago, where, we figured this out, and I think Jack was like, oh, it's geometric, or maybe it was Aiden or somebody, and mentioned to him, was like, oh, the common ratio is x. And then I said, well, then does it make sense that x has to be between -1 and 1? You're like, oh, that's right, the common ratio has to be between -1 and 1. And did we not just prove this using the ratio test? So up to this point, we kind of just used sort of a common sense approach and said, well, if it's geometric and the common ratio is like outside of this -1 to 1, then the numbers are just going to get bigger and bigger and bigger. So like from a common sense perspective, you thought, well, of course, yeah, the common ratio has to be between those numbers of -1 and 1. We've actually proved it analytically here using the ratio test. Make sense? Okay, so this is going to lead us into our 4 super important series that if you don't already have them memorized, you need to. And you will at some point or another get there. So for those of you that are flashcard people, this might be a worthy flashcard exercise. Or maybe if you're more of a verbal, auditory person, maybe you need to say these a bunch. Maybe if you're more of a kinesthetic person, maybe you need to write these down once a day for the next, 6-7 days or something, and then you'll have them. I'm hoping that you already have some of them, or at least very, very close. But these are the 4 power series that we will base almost everything that comes next. We'll base all of it on these 4. So, to give you an analogy, not knowing these 4 series really well and trying to proceed forward would be like me saying, hey guys, let's play basketball. And you say, cool, that sounds like fun. And I show you a basketball and your first reaction is, what's that? What do we do with that orange thing? Like if you don't know what a basketball is, odds are pretty good you don't have a clue how to play basketball, right?
Yeah, Logan.
Or if I said, can you imagine, sometimes this feels like this happens in some of like my Algebra 1 class. I'll say, hey guys, we're going to do an example and I want you to try this. Get out your pencil and write. What if I said, get out your pencil and write, and they picked this thing up and they're like, is this a pencil you refer to? They have no hope, right? So if you don't know these well, you don't have much hope. Okay? Because what we're going to do with these is we're going to take these and use them as a starting point. And in order to use them as a starting point, you kind of got to know which one to use as a starting point. So if I were to say which one has only odd degrees, you would want to say, yeah, which one has the factorials and the exponents that always match? That's e to the x, right? What's the simplest looking one? I agree, yes. Like you'd want to have all these characteristics, both formal and informal, really solidly lodged in your brain. So if you were to look at some future question and say, oh, I bet you that's that geometric thing, but what's that series again? Can't remember. Not much hope for you. But if you say, oh, it's geometric, and I know the geometric is, da-da-da-da, you write it out, and you're like, oh, okay, I just need to do this and this, and you're done. Obviously, there's a lot of hope for you, right? Because you know where to start, and you know what that thing looks like, and then you can start doing stuff with it. And you'll see what the stuff is as we go through the final few days of our new material. Does that make sense? Let's see if you guys remember any of the intervals of convergence. And I don't know if you do. We've proven either all of these or 3 of the 4 of these, and we just proved one of them.
I was like, I have the last one.
We just did it, right? So what's the interval of convergence for the last one? Well, like I said, we just proved it. So this one would be valid for -1 is less than x, which is less than 1. All right, so that's the interval of convergence for the final one there. Do you guys remember any of the other 3? They are all negative infinity to infinity. That's true, they are. So all 3 of these are valid for all real numbers. So you'd want to make sure you have those solidly in your memory as well. So we'll see how it's going. Like over the next week and a half. If I feel like we have an extra 5 minutes at class, I'll probably have you all go to the board and I'll say, write the power series for sine and see if you can do it. And if you can't, you can peek around and say, oh, yeah, Logan got it. I'll just copy him, and there we go. Or, hey, what's the power series for e to the x? Oh, this time Santi got it and Nick didn't get it right, so look at Santi or something, right?
It's not that backwards.
I feel bad for him because he just got demoted, so I'm going to try to prop him back up a little bit.
I understand.
Okay, so, make sense? Here's an example of something you might see. So, like I said, we're really transitioning into the kind of the final things we're going to do with these power series. So take a look at this. Can you imagine if I threw this at the AB students? I said, hey guys, I got this long string of numbers being added and subtracted here. And I said, what does this equal exactly? They would have no idea what I'm talking about, right? But maybe you would. So look at the series above and see if you can get a little match going on there and think, okay, what seems to go with what? And see if you agree. Jack has said he thinks the answer is 0. See if you agree or disagree and have a good reason for that. So think it over. Anybody disagreeing with Jack, or are we all just saying, yep, I think it's 0?
If that perfectly matches sine of x for all real numbers.
Okay, that's right. So is this not a great match for this? So listen, I bring this one up specifically, listen please, because this is a really nice example of some of the ways you'd want to be super familiar with the power series. Because if you look at this and you think, man, it looks like a power series, but I don't know which one, there's not much hope for you. Okay? You're going to struggle with what comes next. But if you look at this and you say, oh, everything's odd. Everything's odd. What is that? Okay, not e to the x. Cosine, everything's even. Oh, is this sine? And maybe you think about that power series there and you say, yes, indeed. If I had, the number of terms approaching infinity, I could say that this exactly equals sine of x, right? Well, then what's been put in place of the x's?
Pi.
So this would equal sine of pi. And what's sine of pi? Turns out Jack was right. It's really 0. Okay. So do you see what I mean by the idea of you need to be like, I'll use this word, like intimately familiar with these 4 power series. You can't be like, oh, I forgot. Right? Just like you would know your mom, your dad, your brother, your sister's face, you would look at them and say, wouldn't that be weird if you came home today for after school and like, who are you? Get out of my house. Like, it's me. That'd be so weird, right? You want to be that familiar. Well, for other reasons maybe, right? Not for lack of recognition.
No, my parents thought I was someone else. Scared the crap out of my parents.
You are a scary guy.
What can I say? My skinny arms and punchable face are just so
They're not.
Punchable face. I don't know if I've ever heard that phrase before. Okay. So here we go. One of the things you can do to a power series, and this sometimes is one of the harder things to do, we'll come back around and visit this later on. One of the things you can do is actually integrate a power series or differentiate a power series. And here's the thing though. The lovely thing about this is, aren't polynomials the easiest thing to do that with?
Yeah.
With possibly the one exception of e to the x. Polynomials are always easiest, aren't they? Because what do you do to either differentiate or integrate a polynomial? Just do a power rule. Do a couple of power rules and you're done. As long as you can add or subtract appropriately, you're good to go. And I know sometimes there is a question mark on that, but the hope is you can. So I thought for number 7, what we would do is give you another chance to find an interval of convergence. So this is a nice, again, I'm trying to segue smoothly from what we've been doing just now to some newer stuff. So take a minute and let's re-practice finding an interval of convergence using the ratio test and endpoint analysis for letter A. So just try this. This is review or continued practice. But then in B, we're going to do some integrals and derivatives. C, we'll do some further analysis and work, okay? So try 7A right now. 7A, please. So something we had a BTA is on 94 to 96.
Forgot it. When's the best time to do that? Maybe not today. But
So, so if you want to get technical with the Ballard academic policy, you have the number of days missed equivalent to make up.
I'll see you in a month.
so I missed.
So,
Yeah, you got the receipts.
I'll see you in September.
Yeah, I was like,
But obviously, we're going to need to be a little more efficient than that.
Oh, so yeah, because I was just like 8 days.
I didn't even know.
Just too many. Just too many. Recently, I could probably try to do it tomorrow. And so like, if not, then maybe like
There was that announcement, though.
this one.
Maybe the announcement is everyone but Santi gets to go, and Santi has to stay and make up for all his.
We've had more
And
than
then everyone's
15.
just like,
You won't be
You
alone,
won't be so
Connie.
screwed
I will be there with you.
I think, yeah.
I think that's like
Okay,
11 days.
sorry.
Send me an email.
I'm so behind.
I don't know how to get that.
That's hard to do.
oh, you can split the limits.
It's not.
You can split the limits.
Oh, yeah,
The limit of a product.
Yeah.
Always supposed to
You
be
can
split.
split the freaking limits.
Oh, ouchie.
Yeah, I think, because of course the one with the X in it, the limit's not going to even apply, right?
Yeah.
Yeah, keep that in mind. If the limits exist, the limit of a product is equal to product of two limits. So you can split them up as a product of two individual limits. You guys done? Come on, Talkie McTuckersons, Chatty
It's our
McChattersons.
time to catch up.
No, it's your time to. Just like the connection is not being made by you. Earlier, you're like, oh, I just want to finish. I'm struggling. Connect. See it.
Graduate.
Me too.
I know, I love high school. I do too.
That's what someone says who peaks in high school.
Oh, wow. Hey.
No, wait, what was that? You want on the back?
I loved high school, but I've already spent a couple days hanging out with people up at college. I'm loving that. So will I peak in college, at least?
Yeah, at least
Okay.
in college.
It's all downhill from
Meg's
there.
just gonna play soccer all the
I
time.
peaked
And
in
everyone's
second
gonna be
grade.
like,
Let's
wow,
be real.
Meg is
Like,
a loser that plays soccer.
At Northwestern.
At
Thanks,
Northwestern.
Hayden, you're so sweet.
I know. So fun
I'm
to
so
be around right now.
I'm not gonna lie. Second grade,
Oh, no, I'm gonna be honest.
second grade was lit.
Yeah, no, that's when I first hurt my knee and I had crutches, so I was like, I had people carrying my food. I had my food tray carried.
That
Second
sounds
I
like
felt
a
like a
peak to me.
king. I felt like a king, and I can't lie.
I can't lie.
Did it go to my head?
A little bit. Has it affected me as a grown up? Yes.
Possibly.
I don't know. You guys just don't have the luxury that I do, which I don't have the luxury of like a 60-year-old. But high school was fun, but college was better,
That's what I hear.
and adult life is way better than college.
Really?
Just being honest. Yes.
I can imagine. I think there's something.
Just like be prepared. Just like be open to the fact that your life could continue to improve
That's fair.
as you grow older.
Sounds like maybe
Well, it's usually usually when your life gets worse, it's often, not always, but often related to decisions you made when you were younger. So, not that I've made all perfect decisions, but the one thing I would say is that I don't think I've made like the same egregious error twice, if that makes sense. So I think it's Nick, please, speaking of egregious errors, stay focused. I think as long as you stay focused on, Christ, and as long as you admit to the fact that you make mistakes, but you're not going to make the same ugly ones 2 times, you'll continue to move forward.
You know why I haven't peaked yet, Mr. Anderson?
Why?
Because I haven't met Jesus yet.
That I will have to say would be the peak, right? Can you imagine? Like if you really stopped and thought about that for a second, of like meeting the Creator of the world face to face.
That's gonna be.
Like you throw that out there and you're just like, oh yeah, that'll be interesting to see Jesus. But it's like, calm down. Just think about that for a second. Can you really imagine what that might be like? You can't really imagine. Like when you read Revelation and like John is just freaking out. He can't even really describe Jesus. He's like, his feet are like fiery brass. And you're like, why would you say that? His eyes are like, I can't, what he describes, his hair is like this woolen, bright white, something or other, like that description. It's just like,
Yeah.
John's like words are just failing him. He's just like, I don't even know what to say. Looks like stuff I can't even describe. 17 eyes and 36 wings and all this stuff.
Did
Okay.
he count? Was he like one?
That's what I'm saying. Like, I don't know. I don't know if he's just like, I don't know. There's a bunch of them, right? It's like, maybe he did count. Maybe he was detailed like that. But I think it's safe to say he did not know how to describe what he was seeing. Okay. So, by any chance, did you guys get this at least at the start? Like, we're going from -1 to 1, and maybe we get endpoint convergence or not. Did you guys get to this point?
How are we supposed to solve for C?
Hang on, slow down. So I'm on A still. So as you test out the endpoints, test out x equals -1, you'd get sigma of -1 to the n over n. So what do you think about this? Is that series going to converge or diverge? It's going to converge using what kind of thinking?
Alternating harmonic.
Alternating harmonic, yes. So I'll just say is alternating harmonic, therefore converge on that endpoint. And then if I test out x equals +1, I get something a little bit different. I just get 1 to the n over n, and that is harmonic, therefore harmonics always diverge. Yeah, the regular harmonics. So is harmonic, I'll just put is harm, therefore diverges. So I would get what, -1 is less than or equal to x, which is less than 1. So that would be my interval of convergence for that particular power series. What do y'all think?
Did you have to split the two limits?
Oh, I would be okay if
I
you...
did x to the n, like I just multiply. I was like x n over.
Yeah, like-
the absolute value of x n over n plus 1 is less than 1, and then I just simplified it to x.
If you
The
just
absolute value
went,
of x.
if your path was from here straight to there,
Okay.
I'm fine with that.
Oh.
I can, yeah, you don't need to show like all the L'Hopital's rule steps, although if you do show them, like if you say, hey, L'Hopital's rule applies, go ahead and like actually do them.
Yeah.
But, if you just want to look at that and say, oh, I can see what this limit is, then just take the red path.
We don't have to show L'Hopital's? Like,
In a situation like this, no, I don't think so. I'd be
I spent
okay.
so much time on the quiz doing that.
I would say, looking at this, because let's just be honest, like n over n plus 1, L'Hopital's rule can absolutely be used, but aren't there other options? Couldn't you divide everything through by n?
Yeah.
Couldn't you use the pre-calc trick? You really could. Where L'Hopital's rule really has to be used is if you have something like limit, I'm just going to make something up here, as x goes towards 2 of sine of pi x over x minus 2. Right, so you look at this and you say, oh yeah, well, oh goodness, the limit of the top is 0, the limit of the bottom is 0. I can't do the pre-calc trick because the top's a sine. Sine of 2 pi.
I'm just thinking about the end result.
Oh, well, we can talk about the end result if you want. But you see my point. Like, this is a very different looking function than n over n plus 1.
Yeah.
You can't divide everything through by x and just get an answer right away. But you could do that with the n over n plus 1. So for that reason, I don't think you need to do L'Hopital's rule with what we're doing. But I think you would if you were doing something like that. All right. So you guys have it on your paper. I'm going to remember what this interval of convergence was. It goes from -1 to x to 1 with closed on the left endpoint, right? Filled in left endpoint. Okay, so then B asks us to find the power series for f prime and the power series for the antiderivative of f. So let's think this through. So the power series for f, now remember, the power series for f is exactly equal to f as long as the number of terms approaches infinity. So if I,
On our interval.
say again?
On the interval.
On the interval of convergence, that's right. So let me just remind myself. Okay, so it's, oh, that's right. Okay, so if f on the interval of convergence, I'll put that over here, for -1 to 1, f equals x to the n over n, which is x plus x squared over 2 plus x cubed over 3, right? Plus ... Okay, so let's think this over. If I'm going to try to find the power series for f prime, it's obviously going to be related to this. Okay, so maybe I'll do the polynomial first, and then I'll do the nth term second. Doing the polynomial, not that hard, right? So we'd say 1 plus x plus x squared. Interesting, huh? Plus x cubed.
I have a hunch.
Whoa, very interesting, right?
No, it's the 1 over 1 minus n.
Okay, now let's keep going here. I should be able to then do a derivative of the nth term. So my nth term could look like this, right? Wouldn't it be n times x to the n minus 1 over n?
So it's just x to the n minus 1.
So it would be x to the n minus 1. The n's would obviously cancel, yeah.
So a while ago, you and I were talking about how you can't take the derivative if you can't do a power over the variable as the exponent. So why does that, because it works here, so why does that change here?
So n stands for some number.
Yeah.
So we're talking about the difference between geometric and polynomial, right? So a polynomial will have a variable base with a numerical exponent. Geometric will be a numerical base with a variable exponent. So the x is considered to be our independent variable, and the n, the n is a variable, but the n just stands for some number, like 3, 4, 5, 6, 7, 8, 9, 10. So we're saying n is we're going to treat it like a constant.
Okay.
Does that make sense? I know it can sometimes be confusing, but it's really about the x, right? So I would say x to the a is a polynomial, and we can definitely use the power rule on that. Somebody could look at that and say, well, wait a minute, isn't a variable? Okay, kind of, but we're saying a is some constant, right? If I were to say a to the x, using kind of our customary approach that letters at the end of the alphabet are variables and letters at the start of the alphabet are constant, a to the x would be geometric. You'd have to use the derivative of an exponential to differentiate that. Okay, so far so good? When you guys saw this, you were all like, oh, I know what that is. And you said,
1 over 1 minus x.
yeah, it's geometric, right? 1 over 1 minus x. If you look back on the previous page, or maybe you just remember it, what's the typical nth term for geometric? Like 1 plus x squared plus x cubed plus x to the fourth plus x to the
X to the n.
n, right? Just x to the n. So can you see how this is really the same thing? It's just that we started at a different first value for n.
Yes.
If I wanted to, and this is actually a pretty important point as far as for me grading your papers, if you told me that the nth term was x to the n minus 1, and then I see your string of terms in your power series, what conclusion would I come to as far as where you started with n?
At 1.
N would have to start at 1 for this to work, right? Because what's 1? Isn't 1 x to the 0? I'd say, all right, well, if the first term is 1, they're telling me that it's x to the n minus 1, that means they started at 1. And you don't have to clarify that for me. Like if you write everything clearly, I should be able to tell that pretty quickly, right? It would be something like this. Please don't get all weird and say, ooh, I'm going to make my n start at 117 just to be tricky. You can, but I will count it up and figure out if you're really right or not. So please, keep it simple for everyone's sake, but this is okay. let's look at the other one. So the integral of f. Okay, so like I said, the nice thing about polynomials is finding antiderivatives and derivatives is super easy because you just do the power rule a bunch. So I'm thinking here, the antiderivative would be x squared over 2 plus x cubed over 3 times 2 plus x to the 4th over 4 times 3 plus dot 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 plus, golly, how in the world are we supposed to come up with the nth term for that? Do you know?
Well, yeah.
Well, it's just x to the n divided by n minus 1 times n.
Let's say n plus 1.
Yeah, I think there'd be plus ones, not minus
Or
ones.
n plus 1.
Couldn't we just do the antiderivative of that original nth term? Right, so here's my original nth term for this power series is right there. Why don't I just do the power rule on that? So check it out. It would be x to the n plus 1 divided by the n that was already there times the n plus 1 that we just divided by. So sometimes people get really intimidated by these. They'll say, oh man, they'll see this x squared over 2 plus x cubed over 6 plus x to the 4th over 12, and they'll say, I don't get the pattern. I can't write the nth term. It's too difficult. And I would agree. I think that could be very, very difficult to say, well, how do the denominators go from 2 to 6 to 12? I don't get it, right? Because the numerator is going 2, 3, 4, and where do I start with? Just do the antiderivative of the nth term, and you'll be right. So if you find yourself panicking about how do I find a pattern, there's probably something like that going on where you can just do a derivative, do an antiderivative, and you'll be in good shape. So Jack, earlier you mentioned, what about the plus c? I think I heard you say something about, hey, where should the plus c go? So if I wanted you to actually find the particular solution or the particular antiderivative here, I'd have to give you a little more information, right? There's going to be some plus c there. And the truth is, if c is a constant, let's just say it's 17, just for sake of argument, based on whatever the initial condition is, well then, that wouldn't really even be a part of the power series, right? Wouldn't you say 17 plus sigma?
Yeah.
So something like that, we could just get it out of there and say, all right, so 17 plus all this other junk, and all the other junk. That's what we're really going to focus on. So I wouldn't get too hung up on the C. I think there's one or two coming up later on where we will actually find a C. You'll get some information to do some stuff with that. Yeah. Okay.
So f is the antiderivative of 1 over 1 minus x on the other word with n 1 to 1.
Yeah, it could be written as such. Yeah.
So that means that f, based on the interval, would be negative ln of 1 minus x.
Oh, now you're starting to talk. We'll come back around to that. Yeah. Yeah, you can start like, how could you write a power series? So later on, what we're going to say is, if you want to write a power series for natural log and centered at a certain particular place, you could just do an antiderivative of that. Definitely. Very true. So early up higher on the page, I mentioned something along these lines, and this is what I want to focus on. We'll maybe do like one of these before we go. You can take a power series and you can differentiate it just like we did. You can find an antiderivative just like we did. And if you do, the interval of convergence will remain exactly the same. However, the endpoints might be a little bit different. Okay? So I can look at this red one and I can say, well, I can be for sure that the interval of convergence does this with question marks on the endpoints. Maybe equal to, maybe not. And then for this one, I can do the exact same thing, acknowledging that the endpoint behavior might have shifted a little bit, or it might be the same. We have to test it out to find out. But I know that the centering point has not changed. I know that the interval of convergence has not changed. Maybe the endpoints. Okay? So let's try one of these. Let's try the red one. How about? Make sense? It's the first one we did. So if I wanted to test that out, I'll say f prime equals sigma from n equals 1 to infinity of x to the n minus 1, right? So as far as those endpoints go, I'm going to test out x equals negative 1 first. So if I test this out, I get sigma of negative 1 to the n minus 1. What does that do?
Just alternates forever.
Negative 1, 1.
So it never goes to zero. Which means that it diverges.
Diverges, yeah. So this diverges, and you just want to give a brief note as to what your thinking was as far as why it diverges. You use the nth term test, right? The nth term test does not go to 0, therefore diverging. And then if you test out x equals 1, you end up with obviously something fairly similar. You get 1 to the n minus 1. And what about that? Converge or diverge?
Same result.
Same exact result, right? So for this one, for the, gosh, I probably should have used red here, sorry. Because this matches the red power series above. So for this one, the interval of convergence is not the same as part A. This is double open, right, on negative 1 and 1. So remember on A, it was closed on negative 1, open on 1. Here it's double open. Okay? So like I said, the interval of convergence will remain the same with possible different behavior at the endpoints. Let's just do this in our heads really quick. What about the integral? Your nth term is right here.
They both.
Don't you get basically either negative 1 over 1 or 1 over n squared? So we would actually get absolute convergence on both. So for this one, we'd actually get double closed. Yeah. It's going to be 1 or negative 1 on the top. You could do the full analysis if you want, but it's either going to be 1 or negative 1 on the top, and then n squared plus n, right? Yeah, n squared plus n on the bottom. Well, isn't that a nice limit comparison? Like the difference in the degree is 2. You probably could do the integral test if you wanted to. You could do direct comparison. There'd be at least a handful of tests you could do there.
Is that not just alternating series?
You could do the alternating series test for one endpoint, for the left endpoint.
Yeah.
The right endpoint, you'd have to do integral test or comparison of some kind or limit comparison.
How would you
Yeah.
do integral tests?
Well, you'd have to do partial fractions. You'd have to do the n and the n plus 1, split it, and come up with what the a and the b are. To me, that seems like the least fun of the options, the one that would take the longest and the most space, but I think you could. I think you really could. So the point here is simply integrating or differentiating does not change the radius of convergence or the centering point at all, but you've seen it here. It does potentially change the endpoint behavior. Okay. So it would be so awesome if when you guys came to class tomorrow and we started to manipulate these power series and I said, which one do you think we should use? You didn't all look at me like,
Sine.
what? You're like, we could do the geometric right there. How about sine? You'd have like some good idea and I'd say, well, what is the power series for sine? You'd say, oh, it's blah, 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 instead of like, oh, I don't know. So take a few minutes today. Write them all out. You guys are all like good memory people. Especially if you hit your learning style. Say it, write it, see it, flashcard it, whatever. Write a program for it so that everybody else can see your program. Do something. And I'm ready to go tomorrow.
Mr. Anderson, how do you always end like right on time?
I try. Sometimes I mess up.
Like,
Really a gift. Yeah.
I take peeks at the clock and I'm like, okay, I got 30 seconds left. I better wrap this up really quick.
like I would finish
got
like
it,
half an hour
Have a
early.
good day.
Like I would just fly through all this stuff and be like, oh, thank you.